When chemistry solved the wrong problem perfectly, it worked exactly as intended, flawless results, maximum efficiency, and yet it quietly led everything in the wrong direction. Not because the chemistry was flawed, but because no one paused long enough to ask whether the direction itself deserved that level of commitment. To understand why this matters today, we need to examine how success is measured in chemistry. A reaction is judged by yield, speed, and consistency. If it performs well under those metrics, it is considered a triumph. But chemistry does not evaluate purpose. It only executes conditions. It does not ask why it was set in motion. It does not weigh the downstream meaning of what it produces. It simply performs, and the quality of that performance becomes the only measure anyone tracks. This creates a blind spot because a reaction can score perfectly on every metric and still be aimed at the wrong target. At first, the problem was clear. There was a bottleneck, a limitation slowing progress. Chemistry offered an elegant solution that removed friction entirely. The reaction delivered exactly what was asked for, with no wasted motion. It was clean, efficient, and immediately impressive in its reliability, the kind of result that earns trust quickly and invites few follow-up questions. Industries embraced it immediately. Processes simplified, costs dropped, outputs increased. The reaction became a standard, praised for its precision and reliability. It solved the problem so well that no one questioned whether it was the right problem to solve. Success at that scale has a silencing effect. It closes the door on doubt before doubt has a chance to fully form, and it replaces curiosity with confidence. But solving one variable perfectly can distort everything else. Chemistry optimized for speed ignored downstream effects. Side reactions multiplied, systems adjusted to accommodate the new efficiency, often at the expense of balance. The optimization created a gravitational pull, drawing resources, attention, and infrastructure toward a single pathway, while quietly starving alternatives that might have served broader and more durable goals. This is where the story begins, with a reaction that did its job too well. A perfect solution to the wrong problem, quietly steering progress toward consequences no one had planned for. As adoption spread, the reaction reshaped priorities across entire systems. What had once been a narrow fix became a central pillar. Decisions were optimized around its performance, not its purpose. The original context in which the reaction had been developed faded from memory, replaced by metrics that celebrated output without examining intent. Because the chemistry worked flawlessly, it discouraged reconsideration, metrics improved, targets were met, success validated itself. When a reaction performs perfectly, it silences doubt. It becomes its own justification. The numbers look right, the process runs smoothly, and the question of whether the right thing is being measured quietly disappears beneath the weight of consistent results. But chemistry solves exactly what it is asked to solve, nothing more, nothing less. By removing the original bottleneck, the reaction exposed new pressures elsewhere. Resources were consumed faster, byproducts accumulated, dependencies formed. The system moved quicker, but it moved quicker in a direction that had never been fully evaluated, and the speed itself made course correction harder with every cycle. This is where early tension emerged. Systems that once balanced multiple constraints now revolved around a single optimized pathway. Flexibility faded. Alternatives seemed inefficient by comparison, even if they served broader goals. The reaction had become the benchmark against which everything else was judged, and anything that could not match its efficiency was discarded or deprioritized. Scientists began noticing a mismatch. The reaction excelled in isolation, but when embedded in complex environments, it amplified imbalances. Chemistry was delivering efficiency without context. The precision that made the reaction valuable in a controlled setting became a source of distortion when applied across interconnected systems where balance mattered more than speed. Attempts to adjust outcomes focused on refining the reaction further, higher yield, faster turnover, tighter control. Each improvement deepened commitment to the same path rather than questioning its direction. The logic was intuitive but circular. The reaction works, so improve the reaction. No one asked whether improving it was the same as improving the system it served. The reaction had become indispensable not because it was ideal, but because everything else had been redesigned around it. Chemistry had solved the wrong problem so completely that it became difficult to remember what the original goal even was. The solution had replaced the problem in institutional memory, and with it, any sense that a different path had ever been possible. The conflict intensified when the consequences of that perfect solution became impossible to ignore. Systems optimized around the reaction began showing strain in areas no one had monitored. What was efficient locally became destructive globally. The imbalance was not sudden. It was cumulative, building quietly in the spaces between the metrics everyone watched. Chemistry had removed friction, but friction often serves a purpose. It slows processes. It limits scale. It forces reconsideration. By eliminating it, the reaction allowed demand to grow unchecked. Inputs were extracted faster, waste accumulated sooner, recovery systems lagged behind. The very smoothness that made the reaction attractive had removed the natural pauses where reflection might have occurred. This buildup carried emotional weight because nothing was malfunctioning. The reaction still performed flawlessly. Metrics still looked strong. The damage appeared elsewhere, displaced into environments, communities, and future timelines. The disconnect between internal performance and external consequence made the situation uniquely difficult to address because, by every conventional measure, the system was still succeeding. Experts traced these effects back to the same source. The reaction had optimized the wrong variable: speed instead of sustainability, output instead of balance. Chemistry had followed instructions perfectly, while intention drifted unnoticed. The reaction was not guilty of failure. It was guilty of succeeding at something that should never have been the priority. Attempts to correct course met resistance. Changing direction meant sacrificing efficiency. Questioning the reaction felt like questioning progress itself. The system had grown dependent on the very solution causing imbalance. Institutions, budgets, supply chains, and expectations had all been calibrated to a reaction that could not be removed without dismantling what had been built on top of it. This was the emotional peak, the realization that perfection can be dangerous when applied to the wrong goal. That chemistry's greatest strength, precision, becomes a liability when purpose is misdefined. The reaction had not just solved a problem, it had locked an entire trajectory into place, making it harder to change direction with every passing year. The reaction had succeeded beyond measure, and in doing so, it quietly locked the future into a path that was increasingly difficult to escape. The climax arrives with a fundamental insight. Chemistry did not fail. It delivered exactly what it was asked to deliver. The failure was in framing the problem. By defining success too narrowly, systems rewarded a reaction that optimized the wrong outcome. Chemistry followed the rules faithfully, while purpose slipped out of focus. The discipline that made chemistry powerful also made it indifferent to whether its power was being used wisely. This realization reshapes responsibility. The danger is not powerful reactions, but poorly chosen questions. When chemistry is tasked with the wrong objective, it can lead entire systems astray while appearing successful. The appearance of success is what makes the misalignment so persistent and so difficult to confront. The resolution lies in redefining goals before reactions are scaled, asking what matters beyond yield and speed. Designing chemistry that supports resilience, health, and long-term stability alongside efficiency. It means treating purpose as a design constraint with the same weight as performance, not as an afterthought reviewed once the system is already in motion. This story is not about rejecting precision. It is about pairing it with wisdom. Chemistry becomes safer when purpose guides optimization, not the other way around. Precision without direction is just speed toward an unknown destination. Every reaction solves the problem it is given. The future depends on whether humanity learns to ask better questions before celebrating perfect answers. Sometimes the smallest shift in perspective becomes the beginning of a new future. When